Usually when we talk about buying something, there is this inherent expectation of precision.
Right.
Like, you walk into a dealership, you look at a car, the sticker on the window says $30,000, and the salesperson just points at it.
Yeah, it's a completely binary transaction.
Exactly. You pay the $30,000, you get the car, it is a finished, tangible product. And, I mean, frankly, that's comforting. We like things to be visible, categorized, and just financially predictable from minute one.
We do. It's a clean exchange of capital for a known quantity.
Yeah.
But, well, the second you step into the world of commercial construction and global project delivery, that entire paradigm just shatters.
Oh, completely.
Because you are no longer buying a finished car.
Yeah.
You are pricing a prototype that has literally never been built before. And it's situated on a piece of land that hides, 1,000 geographical secrets.
Which is terrifying if you are the one holding the purse strings.
Exactly. And it's executed by a supply chain that shifts daily based on global economics.
And that reality is the foundation of what we are doing today in this deep dive. For those of you listening, whether you are a commercial manager prepping for a tense client meeting, a contract specialist trying to master project controls, or, you are in the trenches preparing for your assessment of professional competence, your APC, to become a chartered quantity surveyor, consider this your audio cheat sheet.
Absolutely.
We are treating this deep dive as an elite practical masterclass. We are going to strip down the life cycle of a major project and examine the brutal commercial realities at every single stage. So I'm going to come at this from the perspective of a rigorous APC assessor, or maybe that highly demanding client, just pushing on the pressure points.
And I will do my best to survive the grilling.
I'm sure you will.
Well, we really need to move past textbook definitions here. I mean, understanding the mechanics is one thing, but understanding the behavioral psychology, the contractual leverage, and the strategic foresight required to navigate these projects, that is what separates a competent candidate from a masterful professional.
I love that. Let's get straight to the origin point then. We are looking at a project lifecycle, and I always just assumed things kick off when someone starts drawing.
Right, the architect comes in.
Exactly. But there is this phantom phase that happens before a single pen hits paper. The strategic definition, stage 0.
Yes.
If I'm the client and I say, I have a problem, we are out of space, I need a new building, where does the commercial team even begin if there isn't a design to price?
Well, the biggest mistake a commercial manager can make is assuming that I need a building is actually a true statement.
Wait, really?
Oh, absolutely. At that nascent stage, before we even get into formal preparation, the primary job of the strategic advisors is to stress test the client's business case. So a client might be completely convinced they need a massive new corporate headquarters.
Right.
But the strategic analysis might reveal that their current real estate is only utilized at like 40% capacity because of hybrid working models.
I see.
So the solution isn't a $100 million capital expenditure. The solution is an organizational restructure and a lease renegotiation.
So the most successful commercial outcome at this phantom stage might actually be killing the project entirely.
Well, perhaps not killing it, but pivoting it. I mean, if the spatial requirements they're dreaming of are completely misaligned with their available capital, stopping them from entering a multi-year construction liability is a massive success.
That makes total sense. But let's assume the business case holds water. They legitimately need a new asset. Now we step into the actual preparation and briefing phase, stage 1.
All right,
I'm putting my assessor hat on. We are at the very beginning. The architects haven't drawn a single thing, but the client is staring at you, the quantity surveyor, asking for a number. How are you mathematically costing something that literally does not exist yet? It feels like you're just throwing darts at a board.
Certainly feels like dark magic to the uninitiated, I'll give you that. But it is actually a highly statistical exercise.
Okay, walk me through it.
Because we lack a design, we cannot count bricks or measure steel. Instead, we rely on historical data, granular benchmarking, and area-based metrics. So let's say the brief dictates a high-end commercial office in central London, requiring 10,000 square meters of gross internal floor area.
Just a big empty box at this point.
Right. We interrogate our proprietary databases for the last 10 similar assets built in that specific region. We extract the historical cost per square meter, but we can't just blindly apply it.
Because a building built 5 years ago doesn't reflect today's steel prices.
Precisely. We have to normalize that historical data. So we adjust for regional location indices, we adjust for inflation up to the current date, and crucially, we forecast tender inflation up to the projected start date of construction.
Wow, okay.
We then apply that adjusted rate to the required footprint. But you have to remember that bulk number only gives you the baseline shell and core.
You also have to factor in the site itself, right? Because a plot of land in the middle of a green field is very different from a plot sandwiched between two historic cathedrals.
That is exactly where risk identification becomes paramount. At this stage, we are hunting for deal-breaking project risks.
Like what?
Well, what if the site requires severe utility diversions? What if there are heritage constraints or unexploded ordnance from World War II buried in the soil, which is remarkably common in European cities, by the way?
I didn't even think of that.
You have to establish early risk allowances and bake them into the initial financial models.
Okay, let me challenge you on this because this is where I see projects fall apart all the time. If I am the client and I ask you to guarantee a budget at this stage based on your historical data and your benchmarking, how do you protect me commercially without throwing so much contingency on top that the project becomes instantly unaffordable and just loses momentum?
That is a classic trap, both in reality and in an APC interview.
I knew it.
The fundamental mechanism of protection here is semantic clarity. You have to sit the client down and brutally articulate the difference between a budget and an estimate.
I always thought they were basically the same thing. Break the mechanics of that down for me.
They are definitely not synonyms, and conflating them causes catastrophic litigation later. A budget is the financial boundary. It is the absolute maximum envelope of capital the client has available or is willing to deploy to achieve their business case. It is a rigid ceiling.
Okay.
An estimate, however, is our professional prediction of what the evolving design is currently going to cost. At this early stage, we produce an estimate specifically to test the feasibility of the client's budget.
Ah, I see. So if your benchmarked estimate comes in at $50 million and their locked budget is $40 million, you have an immediate strategic misalignment.
And that is the conversation you must have on day one. You protect the client by clearly outlining the assumptions, the exclusions, and the risk contingencies that form your estimate. You tell them, based on your brief, the market says this will cost $50 million. We have to either increase the budget, reduce the spatial requirements, or accept a lower quality specification.
You just lay it all out.
Yes. You never ever guarantee a final cost when all you have is a brief.
That makes a lot of sense. So the budget is the wallet, and the estimate is the shopping list. And right now, the shopping list is just a vague idea of we need groceries.
That's a great way to look at it.
Now, I want to touch on something that seems to get swept under the rug early on. Who is actually responsible for designing all these different parts? If we don't figure that out now, doesn't it just create chaos later?
It creates chaos and massive, massive financial claims. This brings us to the most critical administrative document of this phase, the responsibility matrix. For anyone preparing for a professional assessment, explicitly referencing the responsibility matrix here is a massive green flag.
What exactly is it? Is it just a list of names and companies?
It's much more rigid than that.
Yeah.
It is a contractual matrix defining exactly which consultant is responsible for which element of the design and up to what stage.
Give me an example.
Okay, if the matrix does not clearly state who is responsible for the specialist acoustic design, is it the lead architect? Is it a bespoke acoustic consultant? Or are we pushing that risk onto a subcontractor later down the line? You will end up in a dispute.
Right, everyone will just point fingers.
Exactly. If it's ambiguous, the architect will claim it wasn't in their fee proposal, the subcontractor will refuse to do it without a variation, and the client will end up paying twice. Setting the responsibility matrix tightly at the beginning protects the commercial baseline.
So we've defined the brief, we've set the budget envelope, we know who is supposed to be doing what. The architects take all of this and retreat to their studios. When they come back, we have transitioned into stage 2 concept design.
Right.
The vision is taking physical shape, they've got massing models, preliminary sketches. How does the commercial team's approach change now that there are actual lines on a page?
Well, we undergo a major transition in our costing methodology.
Yeah.
We abandon the blunt instrument of bulk, benchmarking that simple cost per square meter, and we move into elemental cost analysis.
Okay, so it gets more detailed.
Much more detailed. The design team has produced an architectural concept that is now aligned with strategic engineering principles. So we aren't just looking at generic space anymore. We have a rough structural grid. We have an assumed facade type. We know if the mechanical plant is going in the basement or up on the roof.
So you can start pricing individual elements. You can look at the concept and say, okay, the structural frame is likely steel, the facade is a unitized glass curtain wall, the substructure needs piled foundations.
Precisely. We produce an initial, formal cost plan accompanied by an outline specification. But while the math is getting more granular, the single most critical commercial decision of the entire project lifecycle happens right here.
Which is?
This is the stage where the client must lock in their procurement strategy.
Okay, I hear that term constantly. Procurement.
Yeah.
And honestly, it often just sounds like picking a standard contract out of a filing cabinet. But it's much deeper than that, isn't it?
Oh, selecting the contract is the very last step of procurement. Procurement strategy is fundamentally about risk allocation. It is determining the exact boundary line of when design responsibility transitions from the client's consultants to the supply chain, and ultimately, who holds the financial risk for that design working in reality.
Let's dissect the two behemoths in the industry then. Traditional procurement versus design and build, or D&B. If I'm a client who wants absolute meticulous control over every door handle and light fixture, I'm probably leaning traditional, right?
Yes, without a doubt. In a traditional procurement route, the client retains the design risk. They hire an architect and a team of engineers, and they pay them to fully and exhaustively design the building all the way down to the final screw.
Oh, okay.
Once that design is 100% complete, the commercial team packages it up and hands it to a contractor.
Yeah.
And the contractor's only job is to build exactly what is on those drawings.
They just follow the recipe.
Exactly. The contractor takes the construction risk. If they pour the concrete wrong, they pay to fix it. But if there's a flaw in the recipe, if the architect's bespoke roof detail inherently leaks, the client owns that problem.
Ouch.
Yeah, the client must pay the contractor to fix it and then try to sue their architect for professional negligence, which is just a nightmare.
Which is why clients seem to be obsessed with design and build, because on paper, D&B looks like a silver bullet. You just pass all the risk to the contractor.
Well, it is marketed as a silver bullet,
Yep.
but we need to talk about the illusion of risk transfer.
The illusion.
Yes. In D&B, the client's team develops a design to a certain point, usually just enough to lock in the spatial requirements and the architectural intent. Then they hand that incomplete design over to a main contractor.
Okay.
The contractor takes on single-point responsibility. They finish the design and they build it. If the roof leaks, the client points at the contractor and says, "Fix it. It's your design, your problem."
That sounds fantastic for the client. One throat to choke. Why wouldn't everyone do that?
Because risk is not free. Contractors are not charities. If you force a contractor to take on the unknown design risks of a complex building, they will price that risk into their tender. You will pay a massive premium, often a double-digit percentage increase on the preliminaries and margins, just for the privilege of transferring that risk.
So you're essentially buying a very expensive insurance policy from the contractor.
Yes. And furthermore, clients often sabotage their own D&B strategy.
How so?
They pay the massive premium to transfer the risk, but then they can't let go of the control. During construction, the client decides they don't like the light fixtures the contractor chose, and they demand a change.
Oh, I see where this is going.
The second the client starts interfering with the contractor's design, they blur the lines of liability. If the lighting system then fails, the contractor will argue, "We only installed that because you instructed a change." The risk transfer is nullified, but the client still paid the premium.
That is a phenomenal insight. The illusion of risk transfer. So as the commercial manager, you are navigating this procurement choice while simultaneously trying to keep the architect's evolving concept within the budget.
Exactly.
And this invariably leads to the dreaded phrase, value engineering. Now, I have to be honest with you. Whenever I hear value engineering, I just hear cost cutting. It feels like the commercial team coming in with an axe to ruin the architect's beautiful vision. How do you ensure it actually adds value rather than just cheapening the asset?
It is vital that professionals understand the mechanical difference between those two concepts. Cost-cutting is a blunt trauma to the project.
Right.
It is simply removing scope to save money. It's saying we can't afford the gold fixtures put in plastic, or we are over budget, delete the entire top floor. Cost-cutting inherently compromises the quality aspirations and the business case we set back in the briefing phase.
Nobody wants to cost cut. It feels like an admission of failure.
Value engineering, on the other hand, when done correctly, is a surgical procedure. It is the systematic analysis of a design to achieve the exact same function and the exact same quality, but through a more cost-effective methodology. You are not changing what the building does. You are optimizing how it is put together.
Give me a tangible example of how that actually works in practice.
Sure. Let's imagine the architect's concept features a stunning, sweeping, curved glass facade. It is beautiful, but when we run the elemental cost plan, manufacturing bespoke curved glass panels is astronomically expensive and pushes us over budget.
Okay.
A cost-cutting approach would be to tell the architect, lose the curve, make it a flat, boring rectangular box. You've ruined the architectural intent.
Right, the architect is furious.
Exactly. A value engineering exercise brings the facade engineers, the commercial team, and the supply chain to the table. We ask, can we achieve the visual sweeping curve and maintain the exact required thermal performance and acoustic ratings by using standard, mass-produced flat glass panels, but arranging them in a faceted, stepped curve within a bespoke aluminum frame?
Oh, wow. So visually, from 50 feet away, it still looks like a sweeping curve.
Yes. You retain the aesthetic function, you maintain the environmental performance, but because you are buying standard flat glass instead of custom curved glass, you slash the manufacturing and replacement costs by 40%.
That's incredible.
That is value engineering.
Yeah.
And tying this back to procurement, your ability to actually do this kind of VE is heavily dictated by your procurement route.
So.
In a traditional setup, the design is locked away in a silo before the contractor ever sees it, so their ability to offer supply chain innovations is stifled. But in a two-stage D&B route, you can bring the facade contractor to the table during concept design to help you figure out that faceted glass solution before it's too late.
That perfectly bridges us to the next massive hurdle, stage 3. So we've got a beautiful value engineered concept. We know the procurement strategy, but paper doesn't have gravity.
It certainly doesn't.
Before we can actually generate the blueprints for the factory, every single pipe, beam, air duct, and structural column must exist in physical harmony. We move into the spatial coordination phase.
This is the gauntlet. This is where the digital models are smashed together in clash detection software.
Right.
The engineering analysis must validate the architectural concept. You simply cannot have a high-pressure HVAC duct trying to occupy the exact same physical space as a load-bearing structural steel beam. The ultimate goal of this phase is a spatially coordinated design.
Now, while the structural and mechanical engineers are locked in a room fighting over ceiling void space, what is the commercial team doing? Are you just waiting for them to finish?
Absolutely not. As the design becomes spatially coordinated, the ambiguity evaporates. We can actually start counting things with a degree of certainty.
Okay.
We take that elemental cost plan from the concept phase and we subject it to rigorous market testing. We go out to our supply chain network and get real-time pricing on the major packages. We refine the numbers to produce a highly accurate pre-tender cost plan.
Now, in my experience, this spatial coordination milestone is also typically when the client wants to submit their planning application to the city council.
Yes, often.
Getting town planning consent is always a massive bottleneck. But I was reading about timelines the other day, and honestly, if I'm the client, I'm demanding we submit the planning application as soon as we have a basic sketch in the concept phase. Time is money. Why wait until the end of spatial coordination? Why not submit midway through to save months on the schedule?
That is a phenomenal question, and it is a trap that many aggressive project managers fall into. Submitting a planning application midway through spatial coordination is an immense commercial gamble.
Why? If the building looks roughly the same, what does the city council care about the structural grid inside?
Because the inside dictates the outside more than you think. Let's play out your scenario. You submit the application based on the concept sketches. The City Council takes 12 weeks to review it. Meanwhile, your engineers are continuing spatial coordination. A month later, the structural engineer runs a complex load analysis and realizes that the structural columns need to be 30% thicker to support the floor slabs.
Okay, so you just make the columns thicker inside the building. What's the problem?
You can't. If you make them thicker on the inside, you eat into the net internal area, which violates the client's business case for leasable office space.
Ah, right.
So the architect has to push the columns outward. Suddenly, the entire exterior envelope of the building expands by half a meter on all sides. Or the mechanical engineer realizes the air handling units require a much deeper ceiling void, which pushes the overall height of the building up by 2 meters.
Oh, I see the catastrophe. Your building now physically looks different and is larger than what you submitted to the planning authority.
Precisely. Your planning consent, if granted, is instantly invalidated. You have two choices. You either undertake incredibly expensive, compromised engineering gymnastics to force the bigger structure into the smaller, approved envelope, which usually means lowering ceiling heights and ruining the quality, or you have to submit a formal amendment to the planning authority.
Which takes forever.
Yes. That amendment pushes you to the back of the queue, causing a massive delay that completely obliterates whatever time you thought you saved by submitting early. You wait until spatial coordination is finished because you need certainty that the external massing and environmental footprint are locked.
That is a terrifying reality check. Let's shift gears to contract strategy. You mentioned earlier that selecting the actual contract is the last step of procurement. As we finalize spatial coordination, we have to draft the actual legal documents. We have the big three suites globally: JCT, NEC, and FIDIC. How does a commercial specialist choose between them? Because they all basically say, build the building, right?
They achieve the same end, but their philosophical approaches to human behavior and risk management are entirely different.
Okay, let's break them down.
If you are operating primarily in the UK, and you have chosen a traditional procurement route where the design is fully fixed, the JCT, the Joint Contracts Tribunal, is the standard. It is widely understood by the market. However, it is fundamentally a retrospective, slightly adversarial contract.
Adversarial.
Yes, it relies on a master-servant allocation of risk. The architect says, build this, and the contractor builds it.
And what if things go wrong?
Under JCT, when things go wrong, the contractor tends to gather up all the evidence, put it in a massive lever arch file, and slam it on the commercial manager's desk at the end of the project, demanding more time and money. It deals with problems after the fact.
That sounds like a recipe for a massive final account dispute. What is the alternative?
The alternative is the NEC, the new engineering contract.
Yeah.
NEC was explicitly written to fix the adversarial nature of construction. It is a proactive, management-heavy contract. Its core philosophy is mutual trust and cooperation, but with teeth.
With teeth?
Yes. It forces the parties to deal with problems the moment they arise.
How does it force them?
Through rigorous, time-barred administrative mechanisms, which we will dive deeply into during the construction phase. But essentially, if you want collaborative risk sharing and early contractor involvement, NEC is your vehicle.
Got it.
Now, if you are building a hydroelectric dam in the Middle East or a major railway infrastructure project across borders, you leave JCT and NEC behind. You are in the realm of FIDIC.
The international standard.
Yes. The FIDIC suite is color-coded. The red book is for employer design traditional builds. The yellow book is for contractor design plant and design build projects. The silver book is for turnkey EPC projects where the contractor takes almost all the risk.
Wow, okay.
FIDIC is highly procedural and relies incredibly heavily on a named individual called the engineer to act as the initial, impartial adjudicator of all disputes before they escalate to arbitration.
We're going to dig into the blood and guts of those claims mechanisms in a minute. But before we leave spatial coordination, what happens when you are drafting these contracts and there is a piece of work you simply cannot design or price yet? Let's say you have to dig a massive basement. And despite your surveys, you don't really know what's buried in the soil. You can't just leave it out of the contract, right?
No, you must account for it financially. This is where the quantity surveyor utilizes a provisional sum. A provisional sum is a specific allowance of money written into the contract for work that cannot be fully defined or accurately priced at the time of tendering.
Now, assessors love asking about the difference between a defined and an undefined provisional sum. What is the mechanical difference?
The difference dictates who holds the schedule risk. Let's use your basement example. A defined provisional sum means the design isn't fully finished, but we know enough about the scope to define its parameters.
Okay.
We know we are digging a basement, we know it's roughly 1,000 cubic meters, and we know exactly where it is on the site. Because it is defined, the contractor is contractually obligated to make an allowance for that work in their baseline schedule, their critical path, and their preliminary costs, like management time and site security.
So the contractor knows it's coming and has built time for it into their program.
Exactly. When the final design is issued, the commercial manager simply values the work, swaps out the provisional sum for the actual cost, and the project moves forward. But an undefined provisional sum is a completely different beast.
Uh-oh.
This is for work that is entirely unknown. Let's say there's a crumbling historic brick wall on the site boundary. We know we have to do something to stabilize it, but until we start digging, we have zero idea what the structural intervention will be. It could take 2 days. It could take 2 months.
Because it is undefined, the contractor obviously can't schedule it.
Right. And here's the commercial danger. When the architect finally issues the design for that undefined work, the contractor gets paid for the cost of the work, Plus, they are legally entitled to claim additional extensions of time, and they get paid additional preliminary costs for staying on site longer.
That's a blank check.
An undefined provisional sum is a massive, unquantifiable risk for the client.
So the ultimate strategy for a commercial manager during this phase is to ruthlessly hunt down every undefined provisional sum in the draft contract, interrogate the design team, and force them to define the scope as much as possible before going to tender.
Spot on. You are trying to squeeze ambiguity out of the contract before the market prices it. Which brings us to the information engine. Stage 4. We transition out of spatial coordination and into technical design and tendering.
Space is coordinated. The contract strategy is set. Now we must generate the exact manufacturing data, the blueprints for the factory. But this is where the procurement strategy we chose earlier really bears its teeth.
It does. Stage 4 is about producing all the information required to actually build the asset. Every wiring diagram, every rebar schedule, every ductwork bracket.
Yeah.
But the commercial pivot is understanding who is producing that information. We have to understand the difference between prescriptive information and descriptive information.
Break those down for me.
Prescriptive information is the hallmark of a traditional contract. The client's design team specifies the exact physical reality. They say, you will install this exact model of a solid oak door manufactured by this specific company, hung on 3 stainless steel hinges of this exact specification using these exact screws.
Very detailed.
Very. The contractor has no design input. They simply buy the materials listed and assemble them.
And descriptive information.
Descriptive information is the engine of design and build. The design team does not specify the physical door. Instead, they specify the performance criteria.
Okay.
They say, we require a door in this location that achieves a fire rating of 120 minutes, provides 45 decibels of acoustic insulation, and aesthetically matches a walnut veneer. It is then entirely up to the specialist subcontractor to design a door that meets those descriptive criteria, produce the shop drawings, test it, and guarantee its performance.
So we are shifting the liability of the technical design down the supply chain.
Yes. And if we are tendering this out on a D&B route, this exchange of information is formalized through 2 vital documents: the employer's requirements, the ERs, and the contractor's proposals, the CPs.
Let's focus on those. The employer's requirements are basically the massive legal binder containing everything the client wants, right? The spatially coordinated design, the quality specs, the descriptive information.
Correct. It is the contractual baseline. We send the ERs out to the market to tender. The contractors take the ERs, consult their supply chains, and return their contractors' proposals. The CPs are the contractors saying, here is our exact technical solution to fulfill your ERs, and here is our lump sum price for doing it.
But what happens when the CPs differ from the ERs? Because contractors are always looking for an edge. What if they propose a completely different mechanical ventilation system because their preferred supplier gave them a massive discount?
This is where quantity surveyors earn their fees. Evaluating the CPs against the ERs is a forensic, exhaustive process.
I can imagine.
Contractually, once signed, the contractor's proposals generally supersede the employer's requirements. If the client's commercial team fails to notice that the CPs include a cheaper ventilation system, and they accept the tender, that cheaper system becomes the new contractual baseline.
So the contractor basically sneaks in a cost-cutting measure disguised as a technical proposal.
Often, yes. You have to be incredibly vigilant that a contractor's alternative proposal doesn't subtly compromise the lifecycle operating costs or the quality aspirations we set years ago in the brief.
Now, I want to talk about something I have always found bizarre in the D&B world: novation.
Ah, yeah.
Under a D&B contract, the client hires an architect to design the building up to this point. Then the contract is signed, and the client essentially forces their architect to legally switch sides and work for the contractor. I always use this analogy. It feels like hiring a fierce defense lawyer, and halfway through the trial, they are suddenly paid by the prosecution.
That's a great analogy.
How do you commercially manage a situation where the architect, who is supposed to protect the client's vision, now works for a contractor whose primary goal is maximizing profit margin?
Your analogy captures the profound emotional and commercial tension of novation perfectly. The architect absolutely experiences a whiplash of loyalties. On a Friday, the architect is advising the client on how to squeeze the highest possible quality out of the design.
Right.
On Monday, the novation agreement is signed, and the contractor is telling their newly acquired architect, redesign this facade detail to make it 20% cheaper to manufacture.
That sounds like a mechanism designed to destroy the client's vision. Why do it?
We do it to maintain a single point of responsibility. If the contractor hires a brand new architect to finish the technical design and something fails, the new architect will blame the original concept, and the original architect will blame the technical execution. The client is caught in the crossfire.
Oh, that makes sense.
By novating the original architect, the contractor adopts the design history. They can't blame a concept that their own architect created.
But how do you stop the contractor from forcing the architect to value engineer all the quality away?
The defense mechanism is the employer's requirements. To extend your lawyer analogy, the ERs are the ironclad laws that the lawyer is bound by. If the ERs are incredibly detailed, robust, and tight, the contractor's ability to force changes is severely limited.
Okay.
The architect can say, I cannot cheapen this detail because it will violate ER Clause 4.2. But if the ERs are loose and ambiguous, the contractor will drive a truck through those loopholes, and the architect will be legally bound to help them do it. Furthermore, sophisticated clients will often retain a separate client monitoring team to police the novated architect and ensure they aren't deviating from the ERs.
Okay, let's talk about speed. Clients always want things faster. You mentioned early contractor involvement. Let's dig into two-stage tendering, like management contracting or construction management. How does that overlap the technical design phase with the actual construction phase?
Two-stage tendering is deployed when a client is backed into a corner by a non-negotiable deadline, say, an Olympic stadium that absolutely must be ready for an opening ceremony. You do not have the luxury of waiting 12 months for the technical design to finish before starting construction. You must overlap them.
So how do you hire a contractor if you don't know what they are building yet?
That is the first stage. You tender based on fees, profit margins, and general overheads. You select a management contractor not for a lump sum price, but for their logistical expertise. They join the client's team during the technical design phase.
And what are they doing?
They are looking at the emerging design and breaking it down into individual trade packages: groundworks, steel frame, cladding, MEP. As soon as the technical design for the groundworks package is finished, the management contractor tenders that specific package out to the supply chain. This is the second stage.
I see. So you can literally have shovels in the ground pouring concrete foundations, which is stage 5, while the architects are still figuring out the technical design for the roof in stage 4.
Exactly. It massively accelerates the overarching program. However, the commercial caveat is terrifying.
What is it?
The client authorizes the start of construction and signs contracts for the early packages without ever knowing what the final total cost of the building will be. They are totally exposed to market fluctuations for the later packages. It is the ultimate high-wire act of commercial management.
Which brings us to the most brutal arena of all. The dirt, the noise, the conflict. We are entering the manufacturing and construction phase. Stage 5. Shovels are in the ground. The pristine, theoretical budget we've been nursing for 2 years finally meets the chaotic reality of a muddy site, supply chain delays, and human error.
The design team steps back. Their job is mostly done, relegated to answering technical site queries. This phase is entirely dominated by the commercial engine. It is about execution, relentless project controls, and the lifeblood of construction.
Cash flow. Let's break down cash flow. A contractor cannot bankroll a $200 million skyscraper out of their own pocket and wait 3 years to get paid at the end. How does the money actually move?
It moves through a stripped cycle of interim valuations. Usually on a monthly cycle, the main contractor submits an application for payment. They state, "We have completed $20 million worth of work this month." The client's quantity surveyor does not just blindly pay the invoice.
You're not.
They put on their boots, go out to the site, and forensically verify the claim.
So you are physically measuring the work?
Yes. If it's a traditional contract, we have a bill of quantities. I am checking the actual cubic meters of concrete poured against the bill. I am assessing the percentage completion of the steel frame. Crucially, I'm also valuing materials on site, materials that have been delivered but not yet installed.
Right, to keep the contractor solvent.
I calculate the gross valuation, deduct previous payments, deduct the retention percentage, and issue an interim valuation. That valuation triggers a payment certificate, which legally obligates the client to pay the contractor within a statutory time frame.
But what happens when the client visits the site, looks at a wall that is half built, and says, "Actually, I want that wall moved 3 feet to the left"? Because clients always change their minds.
That introduces the absolute bane of construction: change management. Any alteration to the contracted scope of works is a variation. The QS must legally instruct the variation and then price it.
How do you price it fairly so the contractor doesn't just extort the client?
If we have a bill of quantities, we look for an identical item. If they added 50 square meters of block work, we use the block work rate they submitted in their original tender.
Makes sense.
If the work is totally new and there's no applicable rate, the QS must build a fair valuation from first principles, calculating the raw cost of labor, materials, and plant, and adding the agreed contractual percentage for overheads and profit.
But moving a wall doesn't just cost the price of the bricks. Tearing down a wall and rebuilding it takes an extra week. And an extra week on site means paying for an extra week of scaffolding hire, crane rental, site security, and project manager salaries. Time is money.
And this is where the gloves come off. This brings us to claims and extensions of time, or EOT. When a variation or a client-caused delay pushes the project past its completion date, the contractor will claim an EOT to avoid paying crushing liquidated damages, and they will claim loss and expense to recover those prolongation costs.
This is where we need to return to our contract suites. You mentioned earlier that JCT and NEC handle delays completely differently. If I'm a contractor on a JCT project and the client delays me, what happens?
JCT handles time and money as two separate mechanisms. If the client causes a delay, say, they failed to provide access to the site on the agreed date that is a relevant event. The contractor applies for an extension of time, the architect assesses it, and if granted, the completion date is pushed back, the contractor is saved from liquidated damages.
But they don't automatically get paid for the extra time.
No. To get paid for the scaffolding and crane rentals, they must separately prove that the delay caused them direct financial loss. This is a relevant matter. The phrasing in JCT requires the contractor to notify the client of the delay as soon as it becomes reasonably apparent.
Reasonably apparent sounds incredibly vague.
It is, which is why, historically, contractors on JCT projects would suffer a delay in month 2, send a vague email, and then wait until month 24 to submit a massive, complex claim for loss and expense. It is a retrospective nightmare for the client to unravel.
And NEC was designed to kill that exact behavior.
Yes. NEC is ruthless in its pursuit of foresight. It utilizes a mechanism called early warning. If the contractor, the project manager, or anyone else becomes aware of any matter that could delay completion, increase costs, or impair the performance of the works, they are contractually obligated to issue an early warning notice immediately.
Wow.
You don't wait for the delay to happen. You warn the team that a storm is on the horizon. The team then holds a risk reduction meeting to try and mitigate it before it strikes.
Okay, but what if the storm hits? What if the client explicitly delays the project?
Under NEC, any delay or extra cost caused by the client is bundled into a single concept called a compensation event. Time and money are dealt with together, and here is the fatal mechanism: the strict time bar.
The time bar.
If a compensation event occurs, the contractor must notify the project manager within a strictly defined window, typically 8 weeks from becoming aware of the event.
And if they notify on week 9?
If they notify on week 9, they lose their right to claim any extra time or any extra money, completely, even if it was 100% the client's fault. The time bar is an absolute fatal guillotine.
That is brutal.
It is designed to force contractors to administer the contract proactively. You cannot hoard claims on an NEC project. You must deal with them in real time or you forfeit your rights.
And what about the international arena? How does FIDIC handle a massive delay claim on a hydroelectric dam?
FIDIC Clause 20 governs claims, and it is similarly procedural to NEC, but with a different adjudication structure. If the contractor considers themselves entitled to time or money, they must give notice to the engineer within 28 days. If they miss that 28-day window, the employer is discharged from all liability.
Another fatal time bar.
Yes. But uniquely, the notice goes to the engineer. The engineer is a named professional in the contract, often the lead design consultant who has a dual role. They are paid by the employer to administer the contract, but when a claim arises, FIDIC requires the engineer to make a fair determination, impartially. They must act fairly between the employer and the contractor.
That seems like an impossible conflict of interest. The person paid by the client is supposed to impartially decide if the client owes the contractor money.
It is a massive point of friction in international construction. If the contractor disagrees with the engineer's determination, it escalates to a dispute adjudication board, which is an independent panel of experts formed at the start of the project to issue binding decisions and keep the project moving without resorting to courts.
Okay, let's inject a nightmare scenario here. A real APC curveball. We are halfway through construction on a major D&B project. The structural frame is up. The bespoke unitized glass facade panels are currently being manufactured in a factory in Germany. Suddenly, the facade subcontractor goes into administration. They go bankrupt overnight.
Oh, that's a
The
nightmare.
factory locks its doors. The site grinds to a halt. As the commercial manager, what is your immediate hour-by-hour action plan?
Panic is not a commercial strategy. The first 48 hours are critical. Step 1. Secure the physical perimeter. Ensure the insolvent subcontractor's personnel are off the site, revoke their access passes, and ensure zero materials or plant are removed from the site by disgruntled workers.
Right, lock it down.
Step 2. Initiate an immediate forensic audit. We need a definitive inventory of what materials are physically installed, what materials are sitting in crates on the site, and what materials are locked in that factory in Germany.
And this is where it gets legally tricky, right? If you've paid for those glass panels in Germany but they haven't been delivered, who owns them? The liquidator will want to sell them to pay off the subcontractor's debts.
This is why the quantity surveyor must check for vesting certificates. When we agreed to pay the subcontractor for materials off-site during our interim valuations, we should have demanded a vesting certificate.
What does that do?
This is a legally binding document confirming that ownership and title of those specific glass panels transferred to the employer the moment they were paid for, regardless of where they are physically located.
So the vesting certificate is the shield against the liquidator. You show them the paper and say, those panels belong to us.
Precisely. Without it, you join the back of the line of unsecured creditors, and you will never see those panels or your money again. Step 3. We freeze the subcontractor's account. We conduct a final valuation of the work completed up to the point of insolvency. We withhold any retention monies, and we refuse any further payments.
And then you have to find someone else to finish it.
Finally, we look at the main contract mechanisms to initiate a termination of their subcontract and immediately begin reprocurement. The commercial goal is to ensure that the employer does not pay a single penny more than the original contract sum for that facade, absorbing the extra reprocurement costs through the retention monies and performance bonds we held against the insolvent party.
That is an incredibly intense, high-stakes environment, but let's say we navigate all of that. We survive the claims, the insolvencies, the delays. The building is physically standing. The paint is drying. We cross the threshold into stage 6, the handover phase.
The physical dust settles, but the commercial engine is redlining.
The major milestone here is practical completion, or PC. Now, for the layperson, PC just sounds like getting the keys to the building, but commercially, the exact moment the architect signs that PC certificate, a massive legal tectonic shift occurs. Walk me through the mechanics of that shift.
Certifying practical completion alters the legal landscape instantly across 4 major pillars. First, the completion date. The contractor's liability for liquidated damages ends immediately. If they were racking up $10,000 a day in delay penalties, the clock stops ticking the second PC is achieved.
Okay, that's massive for the contractor.
Second, cash flow. PC triggers the release of the first moiety half of the retention monies. Throughout the project, we have been holding back, say, 3% of every interim payment as a security buffer. At PC, we release half of that accumulated plot back to the contractor. It is a massive cash injection for their business.
Why only half? Why not give them all their money if the building is done?
Because the building is never perfectly done. This leads to the third pillar. The defects liability period, or rectification period, begins. This is usually a 12 to 24-month window. We hold on to the remaining half of the retention money as leverage. If a door hinge breaks or a pipe leaks during this period, the contractor is contractually obligated to return to the site and fix it at their own expense. If they refuse, we use that remaining retention money to hire someone else to fix it.
The ultimate leverage. And the fourth pillar.
Insurance and risk transfer. Prior to PC, the contractor holds the overarching all risks insurance for the site. If the building burns down the day before PC, the contractor's insurance pays to rebuild it. The exact second PC is certified, that insurance policy drops.
So the client is on the hook.
The employer must immediately add the new asset to their own corporate property insurance portfolio. If they forget and it burns down the day after PC, the employer suffers a total unrecoverable catastrophic loss.
So PC is an incredibly dangerous time if the administrative paperwork isn't flawless. Now, once PC is certified, the client moves in. But the quantity surveyor enters a nightmare scenario called the final account. I always compare the final account to moving into a beautiful new house, putting your furniture in, sleeping in the bed, but you are still in a bitter, screaming argument with the movers in the kitchen about a scratch table for the next 12 months. How do you prevent the final account from devolving into a legal dispute?
The final account is the arduous forensic process of reconciling the original contract sum with every single variation, every loss and expense claim, every provisional sum adjustment, and every prime cost fluctuation to reach the absolute final adjusted contract sum. If a commercial manager waits until stage 6 to begin this reconciliation, they've already failed.
Why? You have all the paperwork at the end, don't you?
Because memories fade, site personnel move on to other projects, and leverage vanishes. The contractor has their PC certificate. They have half their retention. Their incentive to negotiate reasonably is gone. The practical advice for any professional is to maintain a rolling final account.
Explain the mechanics of a rolling final account.
It means you do not leave commercial arguments to the end. You price and agree on the financial impact of a variation the week it happens in stage 5. You close out provisional sums the moment the subcontractor finishes the work. You agree on delay costs contemporaneously.
Right.
By the time you reach practical completion, the final account should not be a negotiation. It should simply be a clerical summary of agreements that have already been signed off over the last 2 years.
So you fight the small battles continuously so you don't have to fight a war at the end.
Exactly. And once that final account is agreed, and the defects liability period expires with all snags rectified, the architect or contract administrator issues the final certificate. This is the ultimate closure. It discharges the contractual liabilities of the construction and design teams, formally concluding the building contract.
Which brings us to the final frontier, the longest phase of all, stage 7. We are in the use phase. The contractor's trucks have demobilized. The final certificate is signed. The building now begins its true life. What is the commercial legacy of the decisions we made all the way back in stage 1 and 2?
Historically, the construction industry suffered from a fatal blind spot regarding this phase. We built the asset, we handed over the keys, and we walked away. But sophisticated clients now understand that the capital expenditure, the CapEx, the money we spent to design and build it, is only a fraction of the total economic picture.
Right.
The operational expenditure, the OpEx, the cost to run, maintain, heat, and clean that building over a 50-year lifespan will dwarf the CapEx.
We are talking about whole life costing.
Yes. The role of the premium quantity surveyor has transitioned from being a mere capital cost estimator to a holistic lifecycle consultant. Let's look at a hospital. In stage 2, we might have been choosing between a standard, cheap HVAC system and a highly complex, expensive, energy-efficient system.
Okay.
If you only look at CapEx, the cheap system wins. But a whole life costing analysis models the energy consumption, the maintenance schedules, and the replacement cycles over 30 years. The expensive system pays for itself in energy savings by year 7.
And we are seeing this exact logic heavily weaponized in the push for sustainability and the circular economy. It's not just about saving money on energy bills, it's about carbon accounting.
Modern contracts are evolving rapidly in this space. We are moving beyond just specifying materials. We are starting to see performance guarantees written into the contracts. A contractor isn't just guaranteeing the roof won't leak. They're commercially guaranteeing that the building will not consume more than a specific kilowatt-hour limit per square meter per year.
Wow, that's a big shift.
If the operational data proves the building is burning more energy than modeled, the contractor faces severe commercial penalties during the operational phase.
Now, I have to push back here. In theory, that sounds amazing. But realistically, once the final account is paid, the client's capital budget is empty. They don't want to pay a QS or an architect or retainer to stick around for 3 years to measure energy outputs. How is the industry actually incentivizing post-occupancy evaluation, or POE?
That is the structural flaw in the current market. POE, the process of auditing the building in use to see if it actually performs the way we designed it, is often treated as a discretionary nice-to-have that gets value engineered out at the end of the project. But institutional clients, major universities, tech giants, government health trusts are changing this. They mandate POE.
How do they enforce it if the contractor wants to leave?
They embed the requirement for post-occupancy evaluation into the procurement strategy way back in stage 1. They hold back a specific portion of the fee, or they tie future framework awards to the completion of the POE datasets. They do this because the lessons learned from the operational phase of Project A are the critical empirical data points that feed directly back into the Stage 1 benchmarking estimates for Project B.
It creates a closed loop.
Yes. If you don't measure the asset in use, your cost models for the next project are fundamentally ignorant of reality. The quantity surveyor of the future is a data-driven lifecycle analyst utilizing operational feedback loops to refine capital predictions.
Let's take a breath. What a monumental journey. For everyone listening, we have seamlessly navigated the 7-stage gauntlet of global project delivery. We started in the abstract, stress testing the business case, and setting the initial commercial baseline with order of cost estimates.
We did.
We moved through concept design, unraveling the illusion of risk transfer in procurement, and the surgical precision of true value engineering.
We survived the spatial coordination bottleneck, avoiding the fatal trap of mid-stage planning applications. We analyzed the philosophical divides between JCT, NEC, and FIDIC. We transitioned into technical design, dissecting the ERs, the CPs, and the treacherous waters of design innovation.
We entered the mud of construction. We broke down the mechanics of interim valuations, the fatal time bars of NEC compensation events, and the crisis management of subcontractor insolvency and vesting certificates. Finally, we navigated the legal triggers of practical completion, the necessity of rolling final accounts, and the paramount importance of whole life costing in the operational phase. I want to congratulate you, the listener, on surviving this rigorous masterclass, because understanding the why and the how behind these commercial mechanisms, why retention is halved at PC, how an undefined provisional sum destroys a schedule, why innovation requires airtight ERs, is exactly what separates a good candidate from a masterful, chartered professional.
It is about seeing the interconnected matrix, recognizing how a seemingly innocuous decision regarding a responsibility matrix in Stage 1 inevitably ripples through time to become a multi-million-dollar commercial dispute in Stage 5.
Which brings me to a final, slightly provocative thought for you to mull over as you prepare for your assessments or your next board meeting. We talked about the premium QS of the future being data-driven. But look at the horizon. With the rapid, terrifying advancement of building information modeling, AI, and digital twins, will the future commercial manager even need to visit the site with muddy boots to do an interim valuation? Or will a smart contract linked to autonomous drone footage and a live updating digital twin auto-measure the rebar and certify payments in real time on a blockchain?
It is a prospect that threatens to entirely upend the profession as we know it.
Exactly how will you future-proof your career when the algorithm learns how to cost plan from historical data faster and more accurately than a human ever could? We started this by talking about the comfort of the sticker price on a car. Maybe the algorithms will finally give us that perfect, clean, binary sticker price for a skyscraper. But until that day comes, the muddy waters remain, the human element of risk remains, and they need masterful navigation. Keep pushing back, keep questioning the mechanics, and we will see you next time on The Deep Dive.